Hello, math scholars. Here we are doing a warm-up. We're going to eventually be learning 8.6 day 3, but I messed the video up yesterday and I felt terrible about it, so I thought I'd teach you a little bit about the box method and how you do some factoring. So, if you were gone yesterday, we added another method to our methods of factoring, and I actually made a list over here on the board. If you start with 4 terms, you want to use the grouping method. If you start with 3 terms, you're either going to use the old-fashioned method or the box method. Now use the old-fashioned method if there's no leading coefficient, if it's technically a 1. And then you use the box method if there is a leading coefficient other than 1, like 2 or 3 or 4, or in this case, it'll be 6. So this problem here will be box method, right? This problem here is a little bit tricky. Did anybody come up with any ideas on how to deal with it? It's not really box method. I guess the box method might work. Any ideas in the crowd? You actually want to divide out a -1 to start, because having a negative out front of your leading coefficient is just super yucky and awkward. So if you divide out a -1, it's going to switch the sign of everybody. If I would divide out -1 away from -a squared, it would leave me with a positive a squared. If you would divide a -1 away from 12a, it would leave you with -12a. And if you divide a -1 away from -27, it gives you a positive 27. Now you can work on factoring this stuff with what I call the old-fashioned method. And I call it the old-fashioned method because it's the one you learn first, so you learned it a really long time ago. It's like old hat by now, you've done it so many times. But you're thinking of ways to multiply to get a 27 that would add up to a -12. So I'll just run through some choices. 27 and 1, 9 and 3. I saw some people nodding their heads. Yeah, 9 and 3, definitely. But you want to make your 9 a negative and make your 3 a negative, because that way you could add up to a -12. Okay? Well, that one is done. Let's do the second one. Since we have that 6 out front, this is definitely a box method. So if you were gone yesterday, who was gone yesterday? I'm going to pause. Alright, so since we have that leading coefficient of 6, we are going to do the box method. You start yourself off by just making sure there's no common monomial that you can pull out front. Like, you make sure you can't divide any of these by 2 or 3 or something like that. There's no common monomial, so we're ready to rock and roll and place things in our box. You place your first term, the 6x squared, in your upper right box. Is everybody doing this with me in the warm-up section of your notebook? Because this is your warm-up for today. Make sure you have the date 2-6 and you're trying it with me. You're going to stick that -2 in the lower right box. Sure, it's negative. And then you're going to multiply the 6 and the -2 together. And that gives me a -12. And yesterday we drew a circle. We would put the -12 in the circle. I actually like scribbling out the -2, so it doesn't distract me at all. And now I get to do some brainstorming. So I'm brainstorming numbers that will multiply to a -12 and add up to a -1. There's a 1 right there. I'll run down my choices. 12 and 1, 6 and 2, or 3 and 4. What idea do you like? I saw Arjun. He said it silently. 3 and 4, you said? Yeah. He liked the 3 and 4 idea. Now, which one would you want it to be negative?
3?
The 4. Because we need to add up to a -1, so we need the 4 to be a negative. So we're going to put a -4 and a +3 in our remaining 2 boxes and give each of them an X. Now's where it gets weird. You're going to go row by row and column by column, dividing out front common factors. So let's look at row 1 first. It's these 2 boxes. What does a 6 and a -4 have in common that I can divide out of both boxes? A 2. Mm-hmm. And there's also an X, because this has an X squared and this has an X. I'm going to pull a 2X out of my top row. What does a 3X and a -2 have in common? Nothing, right? Do you remember from yesterday what happens if you have nothing in common? What you were allowed to pull out? It's a 1. Awesome. She remembered. So I'm pulling out a +1. I put a plus there to remind myself it's positive. And then I don't necessarily look at my first column and think of what they have in common. I just think 2x times what would give me 6x squared. So I'm reversing my Punnett square. 2x times 3x would be 6x squared. And then I just kind of verify, is 1 times 3x going to be 3x? Yes, so I have verified this whole column works. All right, 2x times what would give me negative 4x? What should go here? Here. And yep, negative 2, perfect. 2x times negative 2 is negative 4x. And then I check. 1 times negative 2 is negative 2. So we're good. What we have along the side, 2x plus 1, and what we have along the top, 3x minus 2, is our final. Okay. All right, so it's day 3 of factoring. It's not too often you get 3 days of fun on the same exact material, but we have 3 different types of strategies: old-fashioned method, box method, and grouping method. So we're just going to kind of practice all the different things today. Actually, we have common monomial factoring too, so that's technically a 4th type of factoring. Let's just look at the first one together. Just a mix match of a couple strategies going on here. Go ahead and write it down and then we'll talk. So on any problem, before you get into should I box it, should I do whatever, you want to look for common monomial. And if there is a common number or a common variable in all 3 of the terms, you would want to divide that out to the front. So do you see any common monomial? There is one. That's a hint. There is a common monomial. Definitely a 4. I heard someone say 4. Did you say anything about variables? How many R's? 3 R's. Awesome. So we're going to pull a 4R cubed out front. Common monomial factoring. When you pull it out front, you are dividing by 4, so you have to keep that in mind. So if I would take 4R to the 5th and divide out a 4R cubed, do you know what's left? It's almost like you subtract the R's away. You have an R squared left. That makes sense? Let's try the next term. If I would take 4R to the 4th and divide out a 4R cubed, what's left? Good. And it's just 1R. I'm just going to put a 1 there to remind ourselves that it's 1. And then you might need a calculator for this, depending. We're going to take a negative 120 R cubed and divide out a 4R cubed. So all the R's will be gone. But I need to know what negative 120 divided by 4 is. Can you do that in your head or in your calculator? Negative 30. All right, we're not actually done yet. Our fun has just begun. These 3 terms can be factored down even further using what method? Old-fashioned method or box method? Let's recap. You can use the old-fashioned method if it's 3 terms and there's no leading coefficient other than a 1. You can use the box method if there's 3 terms and you do have a leading coefficient other than 1. So what do you guys think? Yep. You could use the box method. It would work for you. But since I don't have a number right here other than like the invisible 1, I'm just going to not waste my time. I'm just going to use the old-fashioned method. And I call it the old-fashioned method because it's so easy and we've known it for so long. We think of numbers that multiply to negative 30 that add up to 1, and we just plop them right in and we're done. Okay? So I'll run through the combinations. 30 and 1, 15 and 2, 10 and 3, or 6 and 5. Which one caught your ear? 6 and 5. Awesome. Which one should I make negative?
5.
Yes. Make it a negative 5, make it a positive 6, and that way it can add up to a positive 1. And then this 4R cubed, you're probably wondering what in the world is he going to do? You're going to keep him out here. I had a student ask, should I redistribute the 4R cubed into these groups? And I'm like, no. The whole point of factoring is to get him out of there, to undistribute things. Okay, that's what factoring means. Undistribute and unfoil. Okay, and that's what we have for our answer. I'm going to put a circle around it. Okay, pretty good. We'll try another one similar to that. All right, we got a lot of negatives on this one. That'll be okay. All right, let's look and think about what the common monomial would be. Any ideas? Definitely want to go with a negative. That's a hint, yeah?
Oh, there's 3 S's.
Yeah, we definitely are going to take an S away from probably every term. I love that idea. So we'll pull an S out. And then what number do you guys think we could divide out of all the 3 numbers? Yeah. Let's go with a -2, just because then everything we'll be left with in here will kind of be positive. And you always definitely want a positive S squared term. So -20 S cubed divided by -2 S. It would actually leave me with a positive 10 S squared. And just to check that I did that right, you can redistribute, is -2S times positive 10 S squared going to give me -20 S cubed? Yeah, so I did that okay. I don't necessarily want to draw that rainbow drawn there. Okay. How about -38 S squared divided by -2S? You can use your calculator if you can't divide that in your head. How's positive 19 sound with an S? And then what's -12 divided by -2? Positive 6. Perfect. Okay, looks good. Now, we're going to take the stuff that's remaining and factor it even further. Do you think we're going to use the box method or the old-fashioned method? We're using the box, and the reason we're using the box is this 10 right here. When this is a number other than the number 1, you definitely want to use box, okay? So draw yourself a box. I'm going to have to make myself some more space. I write too big. We put our 10S squared in the top right box. We'll put the 6 in the lower right box. And if you're wondering what this -2S is going to do, you're going to ignore him for now, and you'll just include him in your final answer out front. But he will not be used in the box at all. All right, so 10 times 6 is 60. I'll put that number in my circle, and I'll scribble out my 6. Now 60 is like 10 million possibilities. So I'll just run down the possibilities and give a holler if you see the one you like. 1 and 60, 2 and 30, 3 and 20, 4 and 15, I believe, 5 and 12, 6 and 10. Did anybody holler yet? Yeah. I was hoping somebody would holler when I got to 4 and 15. I wouldn't have to move on, but nobody said anything because they're too shy. I love the idea of 4 and 15 because they will add up to the 19 that I need. So I'll put them in my remaining 2 boxes with some variables. And now we get to pull out our common terms. So in row 1, they definitely have a 2 in common, and they definitely have an S in common. What does 15S and 6 have in common? A 3, good. And then 2S times 5S would be 10S squared, and 2S times 2 would be 4S. So here's how my final would look. I would have, yeah, question?
Does it matter where you put the 15 and the 4?
No, if you put your 15 here and you put your 4 here, that'd be perfect, that'd be fine. You're going to end up with your 5S and your 2 on this side, and your 2S plus 3 on this side, and that'd be fine. You'll get the same answer. Good question. So 2S plus 3 is one of my binomials, 5S plus 2 is my other binomial, and I had that -2S that has to go out front that I removed way, way, way back at the beginning of the problem. Ooh, these are a lot of work, huh? Are you surviving okay today? You look like you need a snow day tomorrow to catch up on sleep. Promise me you won't stay up super, super late tonight thinking, I'll be good on the snow day, because then you'll be really tired tomorrow if we're here. I'm guilty of that sometimes. I'll stay up super late because I'm banking on the snow day and it just doesn't happen. All right, this one will be so easy compared to the last one, but I put it up here because there's a couple in the homework like this. I want you guys to kind of take the lead. What in the world should we try? What do you think? The good news is there's no leading number other than a -1, so it's probably not going to be a box. Any ideas? Yeah? It is the old-fashioned method. Awesome. Before we do the old-fashioned method, though, just to kind of make it easier, if you would pull out a -1 It's going to make your old-fashioned method work much easier. So if I divide the first term by -1, I'm left with a positive. If I divide the 15x by a -1, I'm left with a negative. And if I divide a -36 by a -1, I'm left with a positive. It just changes all the signs, but it makes that x squared a positive, which is what we're so used to working with. Let's do our old-fashioned method. What numbers multiply to a positive 36 that add up to a negative 15? I guess I'll run down the choices. 36 and 1, 18 and 2, 12 and 3, 9 and 4, 6 and 6, 12 and 3, yeah. And they're both negative, so it's one of those tricky negative situations. There you go. Alright, I think we'll do one more problem. We'll do a solve problem, because those are always a little tricky. One where we solve for x. Alright, so just to recap on how you solve for x, you need to make sure you're equal to 0. We've done these steps before. And you can use your factoring, whatever method works, and then you can use your zero product property to set both of your binomials equal to 0. So first things first, are we set equal to 0 right now in the original problem? So we have to subtract that 3 just to kind of get the 3 over with the other numbers. Okay, so it'll be a -3 minus 3, giving us 4s squared plus 11x s minus 3. Because you cannot combine the 11s with a 3. They're not like terms. Now we could use factoring. What method? Yep, a box. We have that 4 out front. The 4 out front is causing the box. So I will just kind of draw myself a box here. There's some space. 4s squared in the upper left, -3 in the lower right. Multiply them together to get a -12. And now we need to think of our combination first. All right, we need to multiply to get a -12. We want 12 and 1. Do you like 12 and 1? Awesome, I think that's right. Which one should we have be positive? Which one should we have be negative? A positive 12 and -1. Okay. All right. I'm looking at that first row. There's really nothing in common in my first row other than an s, so that makes it interesting. In the bottom row, we have 1 positive and 1 negative. I'm going to go ahead and just pull out a positive 3 in that case. It's when you have 2 negatives, you want to pull a negative out. So over here, I'll pull out a -1. And then 5. Oh, that's an s. I thought that was a 5. That's why I hate s's. S's look like 5s. S's are annoying. T's are annoying. Really, I just like x's. So if this is an s, then this better be a 4s to make it work. And then that works, that works, that works. Checking all my boxes. Okay, so in factored form, here's how this would look. 4s minus 1 times s plus 3 equals 0. That is factored form. Now we just kind of go that extra mile and we solve each binomial. So we set each binomial equal to 0. And we say 4s minus 1 equals 0, or s plus 3 equals 0. I'll solve this one first. It's really easy. We just subtract 3 on both sides. Get s equals -3. And then over here, add 1 to both sides. Space. And divide both sides by 4. So I think positive 1/4 or 0.25 if you like decimals. Put an or between. Okay, I'll leave that up there so you can finish writing. I'm going to give the paper out. It's a paper like we've had before, and again, just do the front sides. These are one-sided papers. Okay.